the second lab in the series. So this second lab focuses on forensic technique investigations. So you're going to have to learn the techniques for forensic investigation and how to use those techniques. So the learning outcomes or the objectives. So at the end of the lesson, you should be able to understand forensic disk imaging principles and how to use the principles, understand file system analysis techniques, also understand evidence preservation methods, and of course, the timeline analysis. So forensic disk imaging. Of course, you know that we are working on containers within Docker environment. So the first thing we're going to do, because what I've done is to break this lab into phases. So phase one is going to look at examining volumes. Okay, and I have commands we're going to run. So within the Docker environment, for instance, we have volumes for MySQL data, we have volume for Elasticsearch data. And then we also have host mounted directories. We have the variable, let me see, when. Yeah, so we have the variable app, it's a mount directory with the /app endpoint. We have the evidence directory. We have the evidence directory. We have the one inside the app directory. Then we have another one standing within the Kali container. Then we have the logs directory. So these are the directories that have been mounted for us to examine. And then we'll look at the evidence directory structure. So when we move into the, of course, for us to make a directory called evidence, there's a command that's make directory evidence and logs. And then we'll move into the project, which is secure server fortress. That's the project. And then that project we have there are directories there, but we're working with evidence for this lab. So inside the evidence directory, we have the attack timeline. We have a secure bank. Of course, we saw this in the previous lab. We also have the network connections.txt. We have the network interfaces, and we have the running processes. We saw 9 items in the log or the evidence directory that we talked about. So for the top timeline, we have the secure band, the rest of them like that. We also have the logs files. We have the logs. We have the disk image. You have the SUUID, the set user ID binaries. Then we have the hashes. Then we'll step back. We have the logs subdirectory that has secure bank directory. So, and then for verifying hashes between lines 39 and 40 of the app.py file, we have these commands: echo, calculating the hashes, and the hashes get stored in hashes.txt inside the evidence subdirectory. So I'm going to sample hash output that we're going to see. We're going to have generate hashes and see how it looks like as we proceed. For integrity checking process, of course, when hashes are created, hashes are meant for integrity check or integrity preservation. So we have initial hash capture. This happened during evidence collection. So when you run, like when we ran the forensics sh command or script that time, so what we do automatic evidence collection. And then we have periodic verification where we compare the current hashes with the baseline. That is, we have a baseline, we have a default hash. So we compare the new hash with that which we had. That is periodic verification. Then number 3, we have temper detection. The temper detection helps to detection helps to compare alerts on ash mismatches where the ash you've gotten does not align with the baseline. That's that is what we got in periodic verification step 2. Do not agree with themselves. That is where you do tamper detection. Then I've already explained chain of custody, where they document all ash verification events. Okay, the events from the first event of collecting evidence to um, the completion of the exercise by reporting, all of that have to be documented. Then we have automated verification, where you do scripting or scripted hash comparison. Usually that is recommended. You write a script that compares the hashes, okay, instead of manual comparison of hashes. So let's go to the script um, again, and then we'll take it up from there. So yes, this lab 2. So phase 1 is where we have to do forensic disk imaging and volume examination, which I just explained. So I've broken this them into phases, and each phase has steps to be taken. So for phase 1, step 1, the job is for us to inspect Docker volumes from Kali VM. All right, so we have to view the volumes by running this command. So just copy this command, and then we'll go to Kali. Kali, let's just log in again. Yes, so just right click this, right click and paste clipboard. Nothing showing. Oh, okay, it means a copy the influence. So let's right click and copy again. And then go back to Kali, paste clipboard. That works. This is to the Docker volume. Not found. Okay, so let's step back. So as I was saying, so the first step is for us to inspect Docker volumes from Kali VM, and we need to view the Docker volumes. But before we do that, make sure you are still within the Kali container by running this command. So let's see the volume that we have. Just copy this, and then go to Kali, and then okay, yeah, we're not in that Kali container. So let's run this quickly first. So let's drop it, right click, and then paste clipboard, and then we're there. Okay, so we can now check the volume. Just run this. Since we are running as root, we don't need sudo. Just copy this and then go to Kali again, right click and paste. So it shows us the volumes available have driver volume and name. So for local, we have the volume is the volume name rather. We have secure server fortress Elasticsearch data, and then another volume we have fortress MySQL data. So those are the two volumes that we have here with that command. So let's see what other thing we have. So the next thing, you can actually run this command to inspect the volume. So we have this to inspect MySQL volume. We have this for the Elasticsearch volume. So we can run one. Let's see, let me try this volume. Let's search this. Copy that, and then go to Kali, and then right click, and then paste clipboard, search. Sorry, that's an error. That 200 shouldn't be there. So let's get that out. Edit that. Says what is it saying? Okay, yeah. Another error at the beginning. It shouldn't be. Okay, yeah. So this volume, these are what we have in that volume. You can see the file created at, you see the date, you see driver local labels, you see them with the mount points, you see, and all of that. So you can also do that for data volume. We've done this is for Elasticsearch data volume. You can do same for MySQL data volume. So step two is to examine host mounted directories by running these commands, one, two. So this first command, um, this is for evidence, and this is for logs. So let's check for evidence. Just run this command, copy, and then go to Kali, and then paste clipboard. And then what's it saying? Cannot access, no file directory exists. Okay, let's see if there's something wrong with that. Let's see. Okay, there's an instruction here to do this outside the containers. So this has to be done with the Kali environment. So let's create a new tab, just a new tab, and then run this here. Paste. All right, so that works. So again, we are here. It shows us those 9 um, logs that we saw initially. So you can also run this to see what you have and this other directory called logs. Then in step 3, we have to inspect the network configuration, where we have to see the container IP addresses and network layout by running this command. So let's try this. Copy and go to Kali, and then let's dump this here. No, okay. This time around, we have to be inside the previous folder, inside the script folder. So we need to go back to this other tab, and then let's run it here. It says, what is that? Okay, let's creating. Where are we now? Creating new folder. Okay, within this one, let's see. List. What do we have there? We have evidence, compose, cleanup, and then let's check what we have in the script since we have in that area. Yeah, this is supposed to be fine for us. So let's try again. Let's try again. Let's go back to Kali again, and then we try this here. That didn't work for us. It should be within the container. Where's the container? Yes. So let's try this. Local network is this. Okay, so this Docker network inspect secure net throws an error for us. So what we need to do is to confirm the networks available. So by running this Docker network ls, so this command, it brings out the list of available networks. So the one we're actually looking for is the last one. Secure Cyber Fortress, Secure BankNet. So that's the one we're going to use. So I've used it here, Secure Network, Inspect, Secure Network Fortress, Secure BankNet. So it gives us the details of that network. You can see name of the network, the ID, the created, that's the timestamp, the scope, the driver, which is bridge, IPv6, whether it's enabled or not, and other details of that network. So these are the things you should see. And of course, that's given us the MAC address of the network and the IP address that we talked about in the Lab 1, 172 whatever update that follows. And other details of the network they hold here. Okay, so let's go back to the scripts and see what we have to do. Okay, it's a script is here, so that's complete phase one of that lab. So now let's look at phase two, which is perform analysis on system file or ES5 system. So we have to be inside the container. So that's on step 4, enter the variable app container by running this command. So just copy this command and then go to Kali and then right click, paste. Boom. Okay, that's okay. So we're looking for app.py. App.py. Is that what you're looking for? Yes, app/app.py. Let's look at the script. Maybe it's not. Oh, sorry, cats. Yeah, I forgot the cats. So let's look at that. Let's just modify that. Cats. This. All right. So this is the scripts. The main scripts, the runnable scripts. You can see beginning from Flask import Flask down to the last line is this app.run that calls the application to run on port 5000. So that is the file, the vulnerable application that we are working on. So the next commands are to show the specific variable lines. For instance, you see the line that can be exploited by cross-site scripting. That is this line 64 to 66. So you can just copy this and then run as let's copy this to terminal and run as well, some is missing. Okay, you can see that you can see that these lines, variability 2, command injection simulated, and this line can be exploited by this command injection payload that one is executed by the attacker. And then, so you can also try that for the rest of the attack types. SQL injection, just copy this. For command injection, try this. Because of scripting, try this, debug, and the rest of them. Then in step 6, we are going to have to examine the templates by running this command. This one is for the login page with the test credentials. We want to examine that. Then for the command injection test link, we run this command. For the Python dependencies, we run this other command. So let's try this one for the login. Copy. Go to Kali, paste that, and let's see that. So this is the login script. Yeah, that begins with doc type down to down to the end of the div or HTML with the closing tab of the HTML. So that shows the login page that can be exploited. Of course, we can see the test credentials there. Let's go back and look at the test credentials. Let's see, you can see here on this line, you see admin 123 the password, and then admin for username, that is for the valid login details. And then, of course, for SQL injection, this is the payload that you can use to attack the application. So go through all of that. And then in step 7, you're going to check application log file. So you use cat to grab that. So cat, let's copy this. Let's go to Kali again. Let's dump it here, paste, and then it shows us the log, the system log. So what we've been doing right from lab 1 is logged here in this file. So we can take time to examine the file to see what has happened, what has logged, what has been done. You can see login attempt, username, admin, and this IP address, login success, username, admin, and the rest of them. Where the login field, for instance, you have one login field, username, admin, maybe the wrong password was given. So the log is dumped in that file, and that's how you can check it out. So let's go back to the script. And then the next thing is to filter the event type. So we have login attempts, like we'll just showed you. We want to filter out the login attempts. We want to filter the login successes, failed attempts, and transfer. For instance, let's see how many times we tried to log in and we succeeded. Just copy this command and then go to Kali. Sorry, it was Kali. Go to Kali and paste it. Yeah, let's run this. So you can see that these are the times we try to log in and succeeded. The timestamp is given. It gives you the date and gives you the timestamp and other details. So 1, 2, 3, 4, 5, 6 times with the times login succeeded. So you can try that out for other attempts like sorry the scripts like login attempts failed or transfer. So in step 7, you're going to have to check database config files by running this command, and you're going to see the hard-coded credentials. And then in step 9, just exit that application. So let's exit that that phase. So just type exit so that we can step out. So we're out. Back to the main project directory. So that concludes phase 2 of the lab 2. So let's look at phase 3, which is on process and network analysis. Let's first of all get into the attacker container. Let's copy this and go to Kali and drop that. Let's see, Kali. Right click and paste clipboard. Again, we have that error of 200. Okay. Let's still see. The command is not clean. Yeah, it's fine now. So back to the script. Let's see. Now let's collect network information. So for active network connections, to run this command and this command. Okay, so let's run this. Of course, one of the log files that we have in the evidence directory is network connection.txt. So let's see what has been collected about the network. Let's see, just paste this here. Okay. Let's see what happens there. That didn't give out any outputs. Okay, that's right. That's correct. So now let's use cat to catch the outputs. Let's use cat to catch the outputs. Yeah, so it shows us the outputs that we have, what has been collected for evidence and then stored in the network connections.txt. You can see the two attempts, the two network interface cards or IP addresses. Then for network interfaces, you can use this command, run this first command, then you use cards to display the outputs. For running processes, you use this command to execute that and then use this card to collect it. Step 13 is where you have to search for log files. So use this command to find that and then use the cat command to display the outputs. Okay, and then in step 14 is for you to get your disk usage reports. Again, use this to execute and then use cat to collect the outputs. Then in step 15, to find the set user ID binaries, use this command to execute and then use the next one to collect. So those are the things you need to do in Lab 3 to conclude that session. Then as phase 4 is on evidence integrity action. Okay. Of course, I said earlier that to establish integrity of the file or a document, we do hashing, and hashing is a one-way encryption process. So for for step 16 rather, or phase 4, you can calculate the MD5 hashes of all evidence that we have collected by running this command. Okay, and then using cats evidence hashes.this. Remember that hashes.txt is one of the files in the evidence directory. So you can use this cat to collect what you executed. Then in step 17 is where you want to upgrade to SHA-256 is recommended. You might choose not to do that. So use this command to do that and then use the cat to collect. Then step 8 is to verify integrity check. So, of course, just run this and the 5 some 6 evidence hashes to collect that. So again, the steps are there for you to implement to conclude phase 4. Then in phase 5, we have to run the automated forensic scripts. Okay. In a previous lab, we ran this file called forensics.ch. So it helps to so this is kind of just reporting what we did before, but for the sake of emphasis, make sure you change directory to the scripts folder, and then allow permission for the file itself, and then execute the file. The outputs are what we showed earlier. So these are the outputs you're going to see once that file is executed. So then in step 20. I showed to us that there were 9 files in the log directory, the evidence directory rather, the 9 files were created. So if you want to see that, just run this command. Let's copy this command and run and see again what we saw before. Copy and paste. So you can see them again. 1, 2, 3, 4, 5, 6, 9 files in that evidence directory that have been collected for us by that. Those files will be generated once this this bash script is executed. So you can see them, attack timeline, secure bank, the rest of them like that. So that's it. So let's go back to what we have in the slides rather. Yes. So we've seen integrity checking process, we've seen hashing and the rest of them. And we've also seen file system analysis, which I've just explained. So these are the lines that we did, like I showed you the commands that showed the different vulnerabilities that are possible. For line 28 to 29, SQL injection can be performed. And then other lines have shown us different attack patterns that can be executed. And then for critical file locations, okay, lines 25 to 27 are possible with command injection. Then transfer functionality can be found in lines 31 to 38. Then the requirements.txt, you see that, okay, what that does for you is to show you the Flask and MSQL connector versions. So again, we continue with the critical files location. This we solve this secure. Let me show you this. This file called securebank.log contains essential log about the application, which I showed you, and then these are some of the things we saw in that file. And then this can actually be seen on line 26. Line 12 to 16 of the application. So the logs are generated from there. All right. Furthermore, for configuration files, Docker configuration files have Docker compose YAML file. We have the variable app Docker file. We have the Docker file for the Kali tools. The Kali tools are used for, of course, executing attacks against the files or against the application that we are working with. So then if you're looking for the application configuration file, then that is where you have the Python dependencies, different versions of those dependencies and the applications, the packages. When you go to the requirements.txt inside the app directory. Then again, for critical file locations, if you're looking for Elastic configuration files, then we talk about the first file, the logstash.conf for configuration, where you have the log passing rules. Then for the Kibane configuration, you go to the Kibane YAML file. Then for database configuration, then you'll be talking about the TP-init SQL. That defines the SQL schema and initial data that your database will have to use. And then for file permissions, so this is a command that reveals the file permission to you. You use the find prime command, which I showed you the script a while ago, and the permission will be stored in the suid_binaries.txt file, and the expected findings in Kali container will be this string you see here, or different parts of it. You see 1 here, you see 2 here, you see 3, you see 4, and then you have the 5 parts of it. For application permissions, once you run this command, you're going to see this different permission files and the lines of codes that are executed. For sensitive data identification, we have one database credentials, which is YAML file, and that can be found in that YAML file, that Docker compose YAML file in lines 36 to 37, 38 rather. You can find that if you look at the environment section of that YAML file, you see that my SQL user is admin, and then my SQL password could be password, or in this case is admin123. Okay, and they also have the application secrets, like I talked about, hard-coded secret key, which is, if for example, it is insecure secret key 123. And I did say that for security reasons, the development team will have to put secret key or some other secret credentials, including database parameters in the .env file in the production environment. And then number 3, we're still talking about sensitive data identification. Okay. And then from the file that I ran, the app.py that I ran, we saw the hard-coded username and password listed, and that is for the valid blogging. And then for your SQL injection, we have you have this payload to run. This for place a password, sorry, username and their password, anything can go there, and that will take you into the application. And then for hard-coded database initialization, this in the users table of the database, um, we have admin, we have John, we have Jane. Okay, so that means if you use any of combinations to log in, you're able to log in. If you use Jane for username and then secure pass for password, then you're in the application. Or if you use John as username, I use password 123, then you're also on the application. So that's it for that aspect. So let's go back to the script and see what other aspects we have to touch. So looking at Elastic Stack, that's in phase 6, we have to do stack analysis using Kibane. Okay, so the first thing we need to do is to step out of the Kali container and then open Kibane. Kibane runs on the browser. So and this is the address for us to access Kibane. So let me just copy that. Go to Kali. I need to log in again. Log in. Yeah. So let's just step out. Yeah, and then launch a browser. Launch a browser. Let's open a new tab and then paste address. Oh, it seems the copy wasn't done, not on the clipboard. Okay, port 5601. So let's see. Okay. Localhost, port 5601. Let's see. Okay, this is listing our Kibane for us. Yeah, it says welcome to Elastic. All right, so we are here now. So let's see what's the next thing for us to do. So we've done what we've done what we have in step 21. Step 21. So now let's look at step 22. In step 22, we are going to do query of Elasticsearch directly. All right, so the step is from Kali Virtual Environment Terminal, you run this command. Run this command from the Kali Virtual Machine Terminal. So let's run the command. Go to Kali and then press this. Okay, so this shows us it shows what you have on the Kibane. You can see the user ID. It's like a hash key. And we see the size, and then we'll see the application or the service. We'll see the state, whether it's open or closed. Then we'll see the color for that. For the logs that we have in Kibane, we'll also see. So the next thing is for us to query the logs. So by running this command again, this command, we can just copy this command to Kali terminal, and then it will show you the query that we have in the logs. So in phase 7, and so in phase 7, which is sensitive data identification, we have some steps starting from step 23. In step 23, you have to find the hard-coded credentials using this command. So we just copy this command and paste, and then look at the database credentials in the Docker Compose file by running this command. Just copy this command, and then also check credentials and HTML templates using the command listed here. And then for database data, just use the grep command to insert this. So that concludes what you have in in phase 7, which is short, and then in phase 8, which is final evidence review from the host. So beginning from step 2 to 4, you are to review or collected evidence from Kali and machine. So you have to exit any container first. I think we did exit. We did exit from the previous one. So once you've exited from container, then run these commands one by one. This list what they have the evidence. This one is going to review the contents of this file. This other command reviews the content of ashes.txt, which we've done initially. So with that, you have come to the end of phase lab 2. But let's see the slides if we have other to touch lab 2. Yes, we talked about running processes in containers by running this command, and then it continues. Yeah, this other command, let's start turned is for you to collect that's to map network connections, and then that continues. Binary. Okay, I've explained this. I'll explain this now. For you to suspect activities that are intended to be malicious or activities that can be classified as indicators of compromise. So when you see unusual process relationships like jar processes spawned from web application, you can suspect something malicious or malicious activity happening to the network or to the application or the device. Or unexpected parent-child relationships in process tree is also an indicator of compromise. Then we have network anomalies. What we call network anomalies could be outbound connections from database container. If you have that, then something is fishy. Unexpected port scanning activity. If your Wireshark is able to reveal, that's your network traffic is able to reveal unexpected port scanning activity, you can suspect something fishy is also happening. Or high volume of connections to log endpoints also reveal something happening. Further, we have file system indicators like new files created in the directory called /TMP during attack. Okay, or you have modified systems binaries or unauthorized cron jobs or scheduled tasks. You can also suspect that something is happening to your file systems. Then for the log patterns, if you experience a rapid sequence of failed login attempts from the log, if you study a log and then you're able to see from the command we did, you do a command that reveals failed login attempts, then you can suspect that something is happening to your network or someone's trying to have access, unauthorized access to your application. Or you have log entries with SQL injection patterns or log entries with command injection patterns. You can suspect that something is actually going wrong with your device. So looking at the forensic script results, the script you run, okay. Now, if you run this forensics .sh command that we did, the file, the script that we ran before, we saw this result. We saw the network information results stored in VSTO files, network connections and interfaces.txt, and then for running processes stored in this running processes.txt, and then for searching for sensitive data or files, we saw that that they are stored in log files.txt. Then for creating this usage report that is stored in this file, let me see. Let me get my pen. Yeah, this is stored in usage, this usage.txt. Then for set user ID binaries, that is stored in the binaries.txt file. And then for ashes, stored in ashes.txt file. And then for it to have the complete analysis results, all of that are stored in the evidence directory that we saw as when we did the experiment. So when we checked this network connections.txt, we saw two entries. So it's possible to have more entries as you run, as you change directory or use cards. Change directory into the evidence folder, then use card to reveal this file. You see the directory, you see the file that are stored there. Okay, then for running processes, we'll also use card to check this file, this running process.txt. Then you're able to see the log in the file. You can see what they do. Okay, then for file system artifacts, we have log files identified from the logs underscore files txt once you use the card to view. Okay, so we are going to see this logs listed here. And then for the disk usage, you find that in disk usage.txt. So you discover, you get to see the file system size, the file system access, to see the size, you see the volume used, you see whether what's the available disk, you see the percentage usage, and then where it has been mounted to. All of this will be revealed in this disk usage.csv file. So in summary, the evidence collected, you see that we were able to see 9 forensic evidence files. We'll find that in that evidence directory with a total size of 2.5. It depends on the system you're accessing. Well, in our own example, the data collected was 2.5 megabytes, and all the timestamped and hashed for integrity files were also collected. So that's it. So the findings, yes, 9 files were seen, total of 2.5, and then these were the evidence, the log files found in the evidence directory. And then many more of them, all of them were found. There were 9 files that we found in the evidence directory from running the forensics.sh scripts. We found that. Now, for analysis methodology, when you've collected your evidence. Now, analysis could be volatile or non-volatile. I mean, other things can follow. We talk about analysis methodology. So you have to select the, depending on the kind of disk you're dealing with, if it's volatile disk or non-volatile disk, we're going to choose the right process to analyze that. Look at what type of network that was gotten from, and the disk to be analyzed. Okay, and then for the approach, you have for the systematic approach, you have the top-down analysis approach. Of course, we also have the bottom-up analysis approach, but the best for systematic approach is the top-down analysis, where you have to analyze your containers and the files in there. But then for integrity focus, hash verification at collection time. So when you're comparing hash, you need to have a baseline of the hash, so that when you collect a new hash, you can now compare with the baseline to see if there's a variation in the hash collected compared to what had been in existence. So that should be the integrity focus of what you're doing. Then for correlation, there's a need for cross-reference of evidence. So of course, that also takes us back to having a baseline of whatever thing you have to compare with. Yeah, like in the normal and in the aspect of establishing the anomaly in either files or your systems, the initial state of the system or the network or the data had to be taken care of before you can correlate with whatever thing you eventually get to do that. And at the end of the day, you have to document, you have to report. So documentation is usually the most critical parts of the analysis, because if whatever you do is not documented or is not properly reported, it's as good as doing nothing. And that documentation, it becomes an essential part of your chain of custody, because from the point of collecting your evidence to the point of concluding your experiment, your analysis, that reporting, that documentation has to be done so that you can know what artifacts you collected, how you use the artifact, how you preserve the artifact, and how the artifact can be used going forward. So, the essential tools and techniques that we've touched, some of them and many more in the course of do your ethical hacking and your forensic analysis. I've shown the use of NetStat, the use of PS, NetStat for network connection analysis, PS for process examination, the find command for finding system searching, and then the tier for the system and usage analysis. Then we have the MD5 sum for integrity verification. Yeah, then we have the IP for network interface examination, and then we have the grep. We use the grep for pattern matching in logs. Okay, so these are essential commands, and we have many more. For custom scripts, we make use of 3 major scripts. We make use of the setup script, setup.sh. We use the attack.sh, and we also use the forensics.sh. For this wedding lab, we use the forensics.sh because it allows us to do automated evidence collection. Yeah. Then for Docker specifics, the Docker exec we use for container access to access our container. The Docker volume to check the storage that we have, examine the storage, and the Docker network to check. Like when I was using the wrong network, I had to use the network and Docker network to check what we have, what networks have been established. You know the right network to use. Preservation recommendations. There's a need for immediate actions, short-term actions, and also future actions. All of these are needed in the chain of custody. So for preserving your evidence or your data collected on your report, generated or documented, you need, for the immediate actions, you need to implement or you need to recommend to the appropriate units or departments or the IT section, to implement automated evidence collection on security events, like with the use of forensics.sh that helped us to do automated evidence collection instead of manual evidence collection. We need to enable audits for comprehensive system monitoring and configure centralized logging to immutable study, because some of the data or some of the evidence we're going to collect might be volatile, and some might be non-volatile. So you need to have an immutable storage such that what you collect, the data will not evaporate with time. All right. And then for bash improvement or the hash improvement, SHA-256 sum is good enough. Of course, if you run this line of code, this line is going to convert your hashes into SHA-256, which is stronger and more secure and protected for your evidence to be stored for you. We have further recommendations like process improvements, compliance alignments, tooling recommendations, and the rest of them. Now, the key security gaps that we have identified in this lab are: one, some systems lack real-time monitoring. So that is where Kibane comes in. That's where Elasticsearch comes in. Of course, in the next lab, we're going to show you how to work with the Elasticsearch or your Kibane dashboard. The third preservation recommendation is bash improvements. So by running this command, just run this command is able to convert your bash from whatever format into SHA-256 sum, which is more secure, which is more protected to keep your hash and preserve the integrity of the hash collected. So we have further recommendations. For instance, process improvements, implements real-time hash monitoring for critical files. We have compliance alignment. We also have tooling recommendations, which are essential recommendations for forensics analysts or experts to recommend to the right unit or department. Then key security gaps that we've identified so far from this lab are that one, the application that we worked with lacks, of course, most applications lack real-time monitoring. And that is where Kibane comes in. That is where Elasticsearch comes in. So in the next lab, we're going to see how to create a dashboard, how to break in the logs, and how to analyze and monitor whatever activities, whether suspicious or benign activities. And then another security gap that identified insufficient logging. So that is again that is where um, the Docker environment makes it easy for us as we move on. So we're going to see in the next lab. And then weak integrity controls. Some applications like the one we work with lack strong security controls, and even the hashing aspects of the hash is collected. I mean, yeah, the hashing aspect of the security controls. Many of them use MD5, so it's important to implement SHA-256. And then network traffic here. So as a network, as a forensic expert, network traffic capturing using Wireshark or TCP dump, it's essential. So, and then the last one is persistent, limited persistence analysis, which is another security gap that has to be filled when you recommend to the developer or the software team on how to fix some of those things. So that ends the lab 2 on this course. Thank you for staying with me. See you in the next lab.